Good morning, everyone. I'm Mr. Mohamed Demba. I completed my UTE. I studied mathematics as a major and environment as a minor.
Hi, I'm Josephat. I'm a physics major and mathematics minor. I'm the program officer of the city as well.
Hello everyone, I am Fatou Sow and I am a final year journalism student. I'm also the communications officer for the institute. Welcome everyone.
Hi everyone, I am Mohamed, a final year chemistry student at the University of Gambia, and I'm the assistant field and lab technician at the institute. Thank you. Nice to meet you. And CSL.
Good morning everyone, my name is Ben S. Jonga, a BSc holder in environmental science.
So if we think about Earth itself, we can think about a closed system. What I mean is that whatever is here on the planet, in the atmosphere, the ground, and the water, in terms of carbon, it's always going to be here.
What is the topic?
So for the field work then, I mean, we could take, I could take the bottles to do the methane sampling. I'm going to show them in the lecture how that works. And then we can't measure it, but we can measure it and then send them the results or show them the results later.
Okay. But on Mauritius, we'll be doing it, right?
Yeah, we can measure it on Mauritius, right? But not tomorrow.
Yeah. Because some students will be a part of Mauritius.
Then they can also do the measurements on board. Yeah, that's perfect.
We do have microscopes here, but that would mean maybe we have the content net.
Yeah, I can bring it. Yeah.
We have sample bottles, and we can bring them back in here and show them.
Yeah.
That's an added extra activity.
Yeah.
And this is good for just field observation. You look at the mud and look at the creature in the mud flat.
So, let's go to see why mangroves are so important. As said before, mangroves are intertidal forest ecosystem adapted to a wide range of salinity and flooding conditions. So they provide valuable ecosystem services with global economic value estimated at $2.7 trillion per year around the world.
We don't normally seek donation from other institutions in order for us to be able to do the restoration and other activities. So it's always very difficult. I mean, cutting down is easy.
Yeah,
to restore them is always expensive.
Salinity, temperature, oxygen, pH.
Yeah, so can you give him our data log book? So, but that one's very basic. So I think what I'll have you do is create a new log sheet with the parameters that we're going to be using for tomorrow. I think that would be. So this is what we usually give our very basic. So you see, if you want to take this home so you can get an idea of
That's a good
how
idea.
we,
Yeah, that's great.
you know.
Yeah.
And then so the aquatic environment, these are the basic things that they collect.
Okay.
And all the terrestrial environment.
But methane, there's no sensor for it. So what we have to do is we have to take the methane out of the water and measure it on instruments in the lab. And we have one of these on the boat, the Mauritius that's coming actually here today. And so we'll take the sample from the surface, very slow, right? Because we put it in, we don't want a lot of turbulence because that will make the gas come out. We'll fill up the bottle all the way. And when we know the whole volume of the whole bottle, then we take out very gently 500 milliliters in here. So then the water will be about this level. Then we have these atmospheric sampling bags here. They're made of a material that's gas impermeable, so you can take samples of gas and leave them here for several months without contamination. Today was general water quality and looking at a little bit more of the carbon cycle and how temperature affects it. And the more focus was on the practical applications as well, because we're going to go out in the afternoon and try a lot of this stuff, which is a benefit of this course. We're going to do water quality measurements with the groups and measure the carbon stocks in the mangroves and see if we can find some zooplankton to look at in the microscope.
I think it would be better for the plankton
So make sure they're both closed, and then you can put this on your bottle. Screw it on tight, and then shake it for 2 minutes.
You can also take the probe directly, put it into the river, and then the heating will not be as bad.
To sample and take in the average.
Yeah, you can also do that. For example, if someone fill up the second bottle, then we can take a second measurement.
And then 31 point right now, 31.1. But the GPS doesn't change, so meaning we can take it any time. We just need to make sure that we didn't move from where we start taking our.
A good shrimp fishery, and so the adult shrimp will spawn in the coastal water, and we can see the larval stage of the shrimp in the water sample as well.
Expedition up the river starting tomorrow, so we'll go up the river and we'll measure various parameters like temperature, oxygen, generally assessing the ecological health of the river.
We do all work together as crew members with shifts. Everyone is doing the sailings, the cooking, the cleaning. You know, we have very tight schedules, and we are a team.
We're here today in Gambia, and we're very pleased to be here to start the expedition on the mangroves. If I want to go 1 meter below the surface, I want that right at the water surface. Today will involve mostly training the students on board on the techniques, and we'll start in the afternoon on measurements. And the key here is we want to do assessment of the water quality. Good. Get some muscles here. So we want to do greenhouse gas fluxes, methane and carbon dioxide, and we'll go on shore to do assessments of the mangrove carbon stock as well as the carbon exchange from these environments. So do the next steps now. So start with 1 bottle, take out your 500 ml, and then cover it with that cap, and then shake it. That's good. And the back valve? Good. B-O-A. No, that's okay. And we do I think it should be down here somewhere.
So today, together we will be studying the river ecosystem, mangrove ecosystem, and my interest is also in looking into the plankton communities, which is the base of the marine food web. And Gambia is known to be one of the places with very, very high biodiversity and very rich marine resources. And then there's like a tail.
I've been working with Pacifique since 2017, running various science programs on board their two vessels, Fleur de Passion and the vessel we're on today, Mauritius. So it's an interesting environment and a fruitful environment to come into because we have flexibility to use the boat as a floating laboratory.
La mangrove, c'est un milieu naturel très fragile. Et puis aujourd'hui, on sait qu'il y a la levée des mers, il y a le réchauffement climatique. Donc c'est vrai que c'est des enjeux qui peuvent être assez importants. Enfin, toutes les zones là, entre 30 degrés nord, 30 degrés sud, tout ce qui est bras de rivière, rivière haute, c'est des mangroves la plupart du temps. Donc c'est un milieu naturel très important qui a encore été assez peu étudié. Donc je pense que ouais, c'est une opportunité pour la suite. Le danger, c'est en fait tous ces bras de rivière, il y a des bancs de sable. Et les cartes ne sont pas tellement précises, donc il faut faire attention à ça. Donc je dirais que c'est le principal danger. Donc pas être forcément à marée haute, mais à marée montante ou descendante. Comme ça, on a un peu de marge. Au cas où on toucherait, on aurait 30-40 cm pour pouvoir sortir.
So now we're on day 3. We've left the last station near Banjul and we went upriver about 3 hours, and we're at a temporary station right now until the tide goes out a little bit more and we can move to the final station. So today in the morning we were cruising, we were checking data, discussing it with the students, and now we have the program now. It's 1 o'clock, so they're going to start the first sampling station here. They're going to try to do 2 here, and then the captain's going to move the boat upriver around 4, and we'll do 1 last station in the small tributary at 5 o'clock. So it's the same sampling program that we've done the last few days. In the meantime, the second team's going on land to scout the mangrove situation so we can organize the mangrove sampling for tomorrow around lunchtime.
Half a meter.
Half a meter. Ready?
Yep.
pH 7.56.
7.56.
Percent DO 84.9.
TDS 18.83.
18.83.
This is not changing at all.
No, thank you.
Salinity 23.89.
23.89.
Temperature 23.74.
Close. So when we take the air and the stand up, we try to point upwind so we don't get the petroleum.
But you can find pretty nice.
Thank you. So this way now.
Pressure's not released.
Yeah. See? So you want 30 ml inside here.
Surtout au fait de comprendre comment est-ce que les mangroves séquestrent le carbone au niveau de leurs racines. Est-ce que c'est aussi au fait un des écosystèmes qui séquestre le plus de carbone et qui joue aussi un rôle essentiel contre l'érosion? C'est un peu une zone tampon.
Parameterizations, especially what's interesting is the salt concentration in the pore water, but we also want to look at the total organic carbon and the total inorganic carbon, so we get an idea of how much of the carbon that's captured from the atmosphere is actually stored in the sediments and root system.
for me, it will be the fact that this is the first time I've been exposed to nature this way. And it's been so fascinating to see the mangroves, to see the river, the dolphins, and just nature at large, the biodiversity around us, and just mingling with people from different backgrounds, different cultures, just coming together and making the whole thing fun. And of course, the scientific part as well. It has really been great for me.
Really like to work on improving myself when it comes to the environmental conservation and protection, because that's really what I want to be working on in the future. I really want to work in environmental conservation so that I can really help the local communities who have lost their source of livelihood, because in the Gambia here most of the local community were farmers, and due to the fresh nature of the river Gambia they were able to have large area of land for farming, but now due to climate change issues, sea level rise and saltwater will intrude the river Gambia, thereby causing like the loss of this rice fields. So as a Gambian and as a youth growing up seeing all that, I would want to be an agent of change and make sure that our environment is preserved, conserved for the future. This is like the starting. I can say this is just one step forward, having the knowledge and sharing experience with some of the scientists who are really into the system. So as a student still now, it will give you the heads up, and you will know where to step your foot in order to get to the right direction you are looking into. So basically this expedition is very, very important, especially to me, since I want to hold on to my environmental conservation, in particular environmental chemical engineering and environmental engineering. So it's very, very interesting for me. Yeah.
But I think the highlight for me was yesterday seeing like the Gambian students work with the UniGen students and trying to really understand the mangrove ecosystem. So you had that local knowledge, working with international or scientific knowledge so that we can figure out or learn more about the mangrove forest and the ecosystem. So I think that was my highlight.
The biggest satisfaction for me is to see how the students progress during these several days. Seeing them how they learn about the different sampling methods and teamwork, and they are working together better and better every day. And basically, we see their progress in real time.
Of course, the scientific side, but also there's such a beautiful area, and everybody we encountered from Gambia has been very friendly and helpful and welcoming. Just to be here, and also the teamwork on the boat between the crew and the different institutes and universities that are represented here. It was a really good chance to get to know each other and yeah, share something together in this project.
So you see that it's very, very little methane, almost nothing, and then very little CO2. So 1.2.
Actually, now we are taking samples for the sediment. So here we are taking 2 samples. This one we will use it to calculate salinity and also porosity and granulometry. And this one, we will dry it, and after drying the sediment, we will work on the organic matter and the NOE and also on the metal trace. But this is going to be like just after, maybe like in 1 week or something like this. And on the other side, we are collecting also data from the sediment for the CO2 and methane. And we are actually like collecting it like every 3 centimeters. The purpose is like to have a profile of the methane and the CO2 and also of the metal trace to see like how it's working like through the sediment.
Oh, look at that one.
Oh yeah, it's different. It smells, actually it smells good.